Hello, folks, everyone. Good morning, and thanks for being here on this particular session. Again, you guys are champions, as I told earlier. After crazy party last night, people are still here wanting to learn, so that's really impressive. And we are seeing more people coming in. So as they come in, we'll just keep on going right now. So I'm Dromil Prajapati. This particular session essentially focuses on a little bit of a different mindset which is happening right now. So I have been designing networks for almost 15 years for different customers. And one thing which I want to just make sure we are aware, the CNF in this means carrier neutral facilities. Some people confuse them with cloud native functions, which is different, how those things work. This is mainly focusing on the carrier neutral facility and how that is actually using or making a shift in how people actually, our customers actually design their networks in newer generation. So something about me, Drew Prajapati, been on with Cisco for more than 7 years. I have a CCIE in routing switching service provider and also CCDE. I've been designing networks for almost 15 years for various customers, especially large enterprises, and giving them an advisory on what is the direction of the industry trend and how they are actually helping to maybe enable them to be successful in their competitive market. And one of the biggest shifts which recently came in, especially after the pandemic, is customers started to realize, their infrastructure in their data center sometimes getting aged, and they wanted to transform into something different. And how can they leverage some of the latest technology, especially with the supply chain issues? When they press an order for a servers or whatever compute they require, it takes maybe a few months to years to come, right? And how can they enable with the on-demand scale? Because now people are working from home. How can they shift immediately in a very quick fashion? So we're just going to talk about some of those ideas here. So introduction, from the agenda perspective, we're just going to go about some introduction. Why do we need? Why is CNF? What is CNF? Why it is becoming more cost-effective solution for a lot of customers. Some of the design considerations you would think about in CNF and what you would do to deploy them successfully. The actual deployment example. So I'm going to cover a couple of large manufacturing customers who had to make this shift immediately to get their stuff rolling, again, because of the supply chain issues, and how this thing helped them tremendously. And also, just look at some of the takeaways on how this thing will help in the future. So one of the biggest reasons CNF came into place was a shift to the cloud-first strategy. Customer has an enterprise network of large, massive WAN, whole bunch of campuses, sites, all organically grown over time period. And what happens in that scenario is when they want to, bring in new technologies like an software-defined access or SDA or SD-WAN, or even some of the ACI-like functions, it becomes difficult for them to design with their existing data center in mind, because it might not be able to handle the traffic or the load or the demand of what this new infrastructure actually demands, especially being in a very agile method. So what they have enabled for themselves is, their computing infrastructure was getting old. They placed a whole bunch of orders for the hardware for the new compute. Then pandemic struck. They started to say, okay, the hardware is going to take so much time. It's not going to come in on for us. But we still need to enable. We need to still have our manufacturing plants who are constantly needed. We have our developers who are constantly researching on some of the new stuff. And that thing should not stop. And this is when these customers reached out to us and say, hey, what can Cisco give us in sort of a newer design, which maybe, they're willing to participate in something new, but also want to make sure it's stable, considerate, and all of those things. So this is when this idea of CNF came into play. So CNF is carrier neutral facilities. So there are, if you step back into like old networking days, there used to be, when the internet was kind of booming up, there were about 7 or 8 different NAPs across North Americas. Now there are multiple which are spread out, but there are still the primary 7 or 8. And within those NAPs, you have companies like Equinix or some of the other partners who actually have and provide co-location facilities. And one of the biggest advantage of those NAPs, and especially when I was before Cisco, I was working for a service provider, was just it's a carrier neutral. It's like a hotel for carriers where they can come in and just connect and interconnect with each other to build the internet. That was a fundamental function of that, right? And these buildings are robust. They're like protected by generators and all kind of things. The doomsday come in and they will still run. That's their function. But then a new kind of era evolved. So from NAPs, which are centrally focused on just network connectivity, they had the secondary NAPs, which are focused on a data center compute connectivity. And some of the biggest examples you would see would be like AWS Cloud or Azure or Google Cloud. They're essentially a large compute facility which can just provide all the access and applications you require. Now, you needed some sort of connectivity from there to the main connection or the site. And this is where those CNFs came into play and how to bring that connectivity on. So these customers are going through cloud functions because they want to make sure that if their R&D is happening and if there's some sort of new innovation coming in, they want to quickly spin up their compute and the environment applications, do some testing, and once it's done, they want to decommission that. They don't want to own the hardware. They want to just try to go and pay as you go kind of a method, which was very cost effective in the situation where you're not buying any kind of liabilities, especially in terms of assets, right, which you own. The private cloud and the public cloud needed to be connected together because somehow this application needs to talk. There are still some legacy applications in the data center which needs to talk to some of the public cloud infrastructure. And the biggest pain point was the management of the on-prem data center, right? Because it's costly into staff people, compute, electricity, power, cooling, all of that is pretty much all there in data center, which was also kind of hitting their bottom lines and see how we can get rid of this and reclaim some of the space in the name of consolidation of their buildings or assets which they usually have, right? This is where the CNF piece came into play. So let's talk about what CNF is and why it's cost effective. So think about this scenario where you have an on-prem data center and you have an operational cost associated with it, right? Now, in this on-prem data center, you would have your campus and branches connected to that via large WAN, could be an MPLS, could be a DMVPN, could be any kind of connectivity. Then you have a public cloud infrastructure, you're bringing those circuits in, you're bringing MPLS, you're bringing internet and security stack on it, and any kind of high-speed MAN connections to your other campuses. Now, imagine this building, your head office is somewhere in like a big metro area, and bringing those connections in requires some sort of connectivity from the provider, upstream provider, right? Because in the end, they are just fiber interconnects. So provider will be, giving you access charges, essentially, hey, if you want to bring this fiber in, my CO is 5 miles down the line, then running the fiber through your building or through your condo, which is going to cost you maybe tens of thousands of dollars, or depending on which provider or especially you go. The biggest pain point was the public cloud. It was just not that easily available. And if you go through a major carrier like AT&T or Verizon, they're going to surcharge on top of it to just provide that connectivity. So what we decided was, hey, let's take the routing function of this entire piece and take it into their facility where everything is, right? So you have AT&T, Verizon, or whichever providers you use for internet, MPLS, cloud, everything is essentially connected to one of these NAPs. And if you build, or if you get 1 or 2 racks worth of space and build that infrastructure, just pure routing, no compute, just routing infrastructure which can handle all this connectivity, and all you need is just 1 or 2 just backbone links directly to your data center on-prem or a campus. That's going to significantly reduce your circuit costs, right? This is where the cost effectiveness comes in. Because within that NAP or premises, there is not a huge interconnectivity charge from different providers. And you can build a lot of infrastructure into it, especially when it comes to security stack and all of those things, right? So this is where this entire idea of CNF-based networks came into play. And one of the advantages of this, which is when you're setting up a WAN infrastructure, something like an SD-WAN, which is connecting all of your sites to your on-prem campus, you would also treat CNF as another site, just with more connectivity. So you'd have a higher performance devices because it's just going to handle a lot of bandwidth coming in. But doing so, you're getting two major advantages. First of all, any application which needs to be accessed in the cloud from a site will go directly to CNF using your internet or some sort of a backbone. And second thing is, there's a huge drive now for software as a service, SaaS applications, right? Like Office 365, SAP, and all of that thing. You don't need to transfer that bandwidth through your own network, especially MPLS, which is very, very expensive. Just offer it out locally on the internet. We'll just go out through CNFs and we'll just go access whatever application it needs. There are multiple benefits there, right? And one of the biggest use case for this customer was they were spending roughly, couple of $1 million a month just on MPLS connectivity to provide that on monthly basis, right? Just to have all the connectivity to all the sites. They were able to shift to all 1 gig internet, the cheaper price, which is half the price a month, from 10 or 15 meg MPLS to a 1 gig internet. So they're getting plenty of bandwidth. With the internet, you can do local breakouts, so you can have all the SaaS applications just go out directly and take the best possible route to whichever cloud applications they're accessing, and less overhead on your infrastructure, right? And there are some critical applications where you don't want to offload them, so you can obviously backhaul them to your centralized applications where there's a security stack built in, so you can make sure this is going through some sort of security posture before exiting out of the internet. So possibilities are immense on this particular scenario. So let's look at some of the design considerations of this CNF and how they look. So first of all, look at the overall design. So you have your CNF, which is pretty much all network infrastructure here. You would have, this is again described for a very simplistic approach. Obviously, you would have redundancies and not single links over here, right? But the idea is you might have some set of switches to host some of your critical function, something like DNS, DHCP servers, or one of those equipment, because that is centralized. Every single application or user might be accessing those. Or some of the network orchestration controllers, like if you have a DNS center or APKM or something like that, which could be up there too. Or AP controllers, sorry, for ACIs. You have your core. You have your firewall stack, which is going to connect to your cloud edge, where you can connect to multiple edge or multiple clouds. You can connect to your internet piece, just for pure internet connectivity. This is your backbone connectivity back to your on-campus. And this is your backbone to other CNFs. So this particular customer is a global deployment. Yes, sir, question. With that particular scenario, there is not a major difference in that piece. But what this one gives you additionally is you could treat it as a compact data center, which the other one you cannot. And other piece here is you can build your own security stack as a centralized place and slowly get rid of your entire data center connectivity or dependency in such scenarios. And one of the examples I was just going into here is this customer is a global customer. They have manufacturing plants and offices across the globe in different regions. So we had CNFs, two CNFs per region, which connect via a massive backbone, like a ring infrastructure, right? So if one fails or something happens and a fiber connectivity or something goes down, other ones are going to immediately take on the load and start functioning. And your application resiliency is purely on routing basis rather than figuring out how to route entire application traffic to some other place, right? This is one of those differences. So the last point here is the backbone, which is essentially connecting to other CNFs. Could be n number of CNFs, and just gives you that connectivity. So let's talk about the CNF routing piece, right? So in this particular routing architecture, you would see pretty much a spine leaf architecture. Again, no more than 2 or 3 switches on the access. You only want to connect some very bare minimum critical functions, DNS, DSCP, or some other critical application which always needs to be highly available. You connect those over there. Everything else stays in their respective place, either in cloud or on-prem data center. You would run either BGP or OSPF. You have a distribution switch, and you would just run your SD-WAN with various transports down as well, which will give you connectivity to a wide area of application services. Now, speaking to the cloud function of this, the idea of this particular scenario is the customer has multiple loads depending on what function they're running. So there are a lot of Microsoft-based applications which they were running in Azure. The R&D department was using AWS for their research functions. And there was also a need for IBM cloud connectivity because there are some legacy applications which were hosted by IBM. So this particular infrastructure, essentially you have a pair of routers where you can load balance depending on the load, or you can have one router per cloud, connect that connection to here, and maintain that BGP connection. The benefit of this is in a dual CNF scenario for load balancing or resiliency perspective, if any of the router fails or circuit becomes offline, the traffic will shift over to the other router because they're all connected in the back end. And then routing will shift over to the other CNF, and application access will still be there consistently. So this is where you get this benefit of having multiple clouds. And our routing protocol of choice was BGP because it was able to scale with very granular policies, as well as how we were able to connect with them together. So any questions on the cloud piece before we move? Okay. Going to the internet edge. This is very interesting function. So in our customer deployment, initially we were planning for, we had CNF idea in mind, but we were planning for internet to move all the MPLS connections out and bring internet as a transport for all the sites. But when the pandemic hit, there was a huge requirement for remote access VPNs, and 10,000 users in a single region, they're trying to just kind of doing remote access VPN, uploading a lot of data. We had to come up with some sort of creative solution to work that out. So we were able to get 2 massive internet pipes in, obviously running pure BGP like an internet provider would. You connect them with the network, and they were able to get the resiliency here. So there are firewall clusters, one in the back end to bring access into the network, and there was another perimeter firewalls up in the front to terminate all the VPN connections. So they were able to immediately access VPN connectivity right away from this particular infrastructure. Another benefit of this internet edge is if you have an SD-WAN connection which requires internet transport, you can piggyback off of the same internet connection. And this way, you can save costs of not having too many multiple internet circuits, but a very big pipes, couple of them for redundancy, and have that connectivity as well. So this way, your resiliency also increases, cost goes down, and you're able to quickly turn up. One of the bigger advantages of this architecture is we don't require too much of an equipment to set this thing up from a core or infrastructure perspective. This is one of the biggest points where we were able to accelerate this customer into this design in a much faster pace, especially during the time of pandemic when the remote access was very crucial. MPLS Edge. Now, this is again a link coming in from the MPLS provider directly to CNF. The idea for this was there were so many legacy sites, and while we are transforming them to an internet-based transport from MPLS on SD-WAN, they still needed some sort of an access to their applications. The existing data center was just not able to cope up with some of the MPLS bandwidth requirements, and as the traffic applications were moving to the cloud, bringing MPLS traffic to the legacy data center back down to the core, to CNF, and out to the cloud was just suboptimal from user experience perspective. So we brought an MPLS connection in the CNF itself, so all the MPLS will take the best path routing to CNF directly and go to the cloud especially. Or in the sites where they had centralized internet, which is coming out through the data centers, we forced them to go through CNF because this new security stack for Internet Edge was very robust with all IPS, IDS, anything else required. So they were able to quickly utilize those features so they can start decommissioning the old internet infrastructure on the data centers. And the last bit up here is the core functions, which is connecting to the other CNFs. So the hierarchy was you have CNFs which form a ring topology. Both of the CNFs would connect to some of the key sites in a hub and spoke fashion for the local SD-WAN region. So any traffic going from one region to the other, we utilize those highly reliable backbone connections out to the other sites. This way we do not need to have too many cross connects or logical connections across to the other regions, and provided the best SLAs, especially in terms of latency between the regions. Because they already had those 10 gig E-line services across the pond, right? So it'll be much easier for them to work with. Any questions before we move forward? Okay. So let's look at some of the actual CNF deployment example, right? So if you have all the redundancies and everything in place, essentially this is what it would look like. You would have the core connectivity with everything is dual router. You have two dual backbone routers, MPLS, obviously dual connected up to the core distribution, internet with a huge security stack. With all this equipment in place, we were only needed on just 2 racks, full-size racks, for this entire thing to function. And this was able to transport almost 40 gigs of traffic at a scale without any kind of hindrances or any kind of issues with performance. So this was one of the biggest advantages when they started doing that. Right now at this current stage, after 2 years, this customer has 100% migrated all of the data center applications to the cloud because they had no intention of proceeding ahead with the on-prem compute requirement. And this was what it enabled them. They were quickly able to, with high capacity links, transfer all the applications over and decommission of their data center facilities. So this is something which has been very successful so far. So if you look at the real world analysis, right, on the CNF core piece, if you just double click on each of those segments on what we looked at from the network perspective, on the core of the CNF consists of spine and leaf topology, spine layer, leaf layer, and here we have all the compute and servers. Here we have shown ICE, DNS center. You might have a DHCP, DNS, all of those servers inside. And this is where the distribution layer is. So this distribution layer essentially acts like a WAN distribution. Spines are the just core for the entire architecture. Going to the SD-WAN side of things. So in SD-WAN, so these are connected directly to the distribution layer. And this is the transport side. And this is the service side. So even though we are connecting back on the same distribution layer, this gives you an ability to actually utilize same physical platforms because they are built for performance, like ASR 1002 HXs or something like that, to do high performance routing and still leverage all the connections that's required for these transports. So what you see here is internet, the green connections coming out from the internet, they go through the firewall, and this distribution switch essentially just passes them as layer 2 on the SD-WAN routers. And same thing goes with the MPLS. MPLS don't go through the firewalls as they are trusted links. So this is the transport side of the SD-WAN infrastructure. On the service side, you will have the same connection coming back as a trusted or inside connection of the router connects back to the distribution layer, which essentially goes down to all of the other sites. Either use MPLS or backbone connections or anything else required, right? So taking a step back, distribution layer here, which connects back to the entire core of the CNF and also the other parts of the trusted infrastructure for customer. Right? And the routing protocol of choice here was pretty much BGP up on the northbound towards internet and MPLS. Internally, customers prefer OSPF, which is still doable. It's much more scalable for the environment out there. It was, again, not too many devices, but for that particular CNF core, this was the most effective solution. Any questions on this? All right. Moving down to the firewall considerations, and from the security stack perspective. So again, this could be the same firewalls we saw on the SD-WAN side of things, or could be different. Again, it all depends on the cost and how much you have. The customer had a high-performance firewall platform, so they utilize the same firewall but with different context, which gave them the capability of virtualization and segregating traffic. So this firewalls essentially had upstream had multiple routers. One pretty much connects to the internet, other one connects to multiple clouds. And this distribution layer, again, comes in the picture with the physical links. And this is where the security stack was connected as well. So the firewall provided IPS, IDS functions. There were some threat detection applications which were connected within the CNF core to the leaf switches which you saw earlier, and any traffic coming in with VLANs routing and VRFs, we were able to route the traffic through a proper path so that everything gets kind of inspected before it goes out on the routing perspective. Okay? So CNF core design to the other CNFs. So how would that work, right? So again, this distribution layer, which was a WAN distribution, which connects to all the WAN, connects down to the core or the backbone routers, which connects to other CNFs. Now, these links could be deployed in multiple fashions. So you can have, if you had another customer where they wanted to even subsidize the cost on something because their architecture was a little bit different. So the first customer said, okay, I want to have 2 private connections with better SLAs connecting to all of my other CNFs in the globe, which is what this diagram shows. The second customer says, what I want to do is I want to leverage SD-WAN for global connectivity as a hierarchical SD-WAN. So you have regionalized SD-WAN hierarchy where your local regional SD-WAN headends are in hub and spoke topology. Then your other side of that SD-WAN, the service side, becomes a hierarchy where you have other SD-WAN core routers connected in like a full mesh connection. So when a site in America wants to reach to a site in Japan or Europe, it will go through the local regional SD-WAN hub first. It will transfer back the back link, which is full mesh, to the other region SD-WAN router. Once it reaches there, then we'll go down to the respective sites. So that was an architecture. So for them, internet-based backup CNF connectivity was very feasible because they wanted to have one connection as with a dark fiber-like connectivity with a E-line service. The second one was internet-based, so they were running DMVPN on top of it. So it just gives them full mesh connectivity. So that ended up, saving them some money, especially in the times of, the market crunch which is happening. So this is something which was they tried and tested. It worked out with them. They wanted to just give it a shot before they commit to it. It worked, and they are now sticking with that particular design. So in this particular scenario, what happens is for the internet traffic when it needs to go out of a CNF, so each region, there is a designated CNF, which is a primary gateway out to the internet. So that, and we are controlling that with the default route, which is injected by a firewall locally from that CNF into the routing table. Now, based on the best routing metrics, because we have consistent protocols everywhere, whichever site comes in first, they will be able to go out to that particular traffic, take an exit out of that particular infrastructure. Now, what we were able to do was think about a scenario where you would have, in Americas, they have a CNF in let's say, in East Coast and the West Coast. And it's an active CNF, so you do not know which traffic that the user would take, or which exit the user would take, and you want to be more predictable. So what you can also do is, on the outside of the connection of the routers which are connected to the internet, you can also run BGP between the two CNFs on the external side. What that gives you is, because it's all internet public routing with multi-hop, right? You can we have done with the GRE tunnels as well. What that gives you is, in the event if one of the internet connection fails, or some of the backdoor connectivity from the CNF gets it's not reachable, the user traffic will come to the primary CNF, or CNF-A, can take that exit out so that NAT and translation table doesn't impact the user connectivity. So the idea is, you design a network which is fail-safe from the outside, so on the inside, whenever any kind of disruption happens, the connectivity is still maintained, especially the state and the translation tables, so that the user has a seamless experience. It's completely transparent to them. That was one of the engineering we did. From the CNF interconnection side of things, you can see it's a ring topology here. One of the other CNFs in this case was a US CNF2, which you don't have a connectivity to the other CNF, but you can still have a ring topology here as a secondary ring. Or something like a Latin America, where customers have their businesses over there. We have a CNF there which only connects to the CNF in the Americas, and then everything else goes out to other regions, because it was new to me when I discovered that the links from Latin America to the other regions is very, very expensive. So it's much easier to just transport everything to the US side and then backhaul it to the other regions, because it's almost like double or triple the price of the single connection. So it's one of the saving examples. Okay, any questions?